In the question, it's given that in the arrangement shown in the figure, all pulleys are smooth and massless. When the system is released from rest, acceleration of block 2 and block 3 relative to block 1 are 1 meter per second square downwards and 5 meter per second square downwards respectively, and acceleration of block 3 relative to block 4 is 0. Find the absolute acceleration of block 1, 2 and 3. So in this case, the acceleration of the block 1, 2, 3, 4 all is given in the relative terms. So let us assume that acceleration of block 1 is given as a1, of block 2 is given as a2, of block 3 it is given as a3, and of block 4 it is given as a4. And let us call these pulleys as x and y. So in the first part it is given that the acceleration of block 2 and 3 relative to block 1. So we can frame the equation of block 2 and block 1. Okay. So we can say that acceleration of block 1 is a1 and acceleration of block 2 is given as a2. Therefore, a1 plus a2 is given as 1 meter per second square. So we write here 1. Let us call this equation number 1. And in the second part, acceleration of block 3 with respect to block 1. Okay, so we write acceleration of block 3 is a3. Thus we get a1 plus a3 is also given as 5. Let us call this equation number 2. And the acceleration of block 3 relative to block 4 is 0. Okay, you can see that acceleration of block 4 is a4, and it is given as 0. So you can say that a3 plus a4 is equal to 0, and from this, sorry, here it is minus, my mistake. So here we can say that a3 is equal to a4, and let us call this as equation number 3. Now it is given that they are moving in the downward direction. Block 2 and block 3 are moving in downward direction, and so because of that we can simply frame that there are two ways of doing the equation for the acceleration. One is a more traditional way. We can assume that block 1 moves by x distance and the pulley will be moving by x. So therefore we can say block 4 and pulley y will be moving respectively as a multiple of x, and similarly this can be written with respect to block 2 as well as block 3, or then we can differentiate, double differentiate it, and then we are going to get the equation for the acceleration. Or we can also directly write the equation for the acceleration. There is no need for writing the writing the block displacement in terms of x, and then double differentiate it, and then we are going to get the same equation as we are going to write it for the with the help of a direct formulation. So the relationship between acceleration of block 1, that is a1, will be equal to acceleration of, that is a4, plus a5 divided by 2, and the second part we can write that okay, a5 is the acceleration of pulley y. Okay, we can write here that acceleration of pulley y is equal to a5. Okay, so based on that we can write this is our first part, and in the second part we can also write that a5 is equal to a2 plus a3 and divided by 2. From here we can write that a5 is equal to twice a1 minus a4. Substituting this value of a5, let us say this is equation number 4 and this is equation number 5. So from equation 4 and 5 we get twice a1 minus a4 is equal to a2 plus a3 divided by 2. This can be written as 4 times a1 minus 2 times a4 is equal to a2 plus a3. Now we already know that from equation 3, a3 is equal to a4. We already proved it. So we are going to substitute this value and we get this as 4 times a1 is equal to 2 times a4 plus a2 plus a3. Now we put the value a3 as a4, so we get this as 4 times a1 is equal to 3 times a3 plus a2. And we already know that from equation 1 and 2, we have that a2 is 1 minus a1 and a3 is equal to 5 minus a1. And let us call this as equation number 6. Therefore, equation 6 becomes 4 times a1. We substitute value of a2 and a3. We get 3 times 5 minus a1 plus 1 minus a1, and solving this for a1, 8a1 will be equal to 16, and a1 will be equal to 2 meter per second square. So this is our first part. We got the a1, and from here we can calculate the value of a2, because from equation 1, a1 plus a2 is equal to 1. You substitute value of a2, a1 as 2, you get 2 plus a2 is equal to 1, so it means a2 will be equal to minus 1 meter per second square. And in the third part, we are going to find out value of a3. So from equation 2, we can write a3 plus a1 is equal to 5. We already know a1 is 2, so we get a3 plus 2 is equal to 5, and a3 will be equal to 3 meter per second square. So we got the value of a1, a2 and a3, which was, and these are the absolute values of block 1, 2 as well as 3. So the only difference between previously done question and this one is that the acceleration here is given with as a relative, and second thing, we directly formulated the equation for the acceleration. We did not use the traditional method in which we assume that one of the block move by x, and then we are going to double differentiate it, so that saves a lot of time, but the equation will be coming as same. We can write this as x5 is equal to x2 plus x3 divided by 2, and double differentiation will be giving us a5 plus a5 is equal to a2 plus a3 divided by 2. So we get the same results, and directly we can use the equation for acceleration instead of we making use of the traditional approach where we assume that each block moves by a x distance, and subsequently we divide the x as a divide it as a multiple of x, and respectively we get the, after double differentiation, for the acceleration equation. Thank you.